Hello, and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Luis Fernando Gazcon.
Thanks for the introduction, William. Good day, everyone. Thanks for tuning one more time with your KYZEN cleaning experts. Today, we will be reviewing a case study in the optimization and improvement of an inline PCB cleaning application. Recently, we've had the opportunity of supporting and helping an electronic assembly manufacturer. After running this process for nearly 10 years with a competitor pH-neutral chemical, this EIC manufacturer gave KYZEN the opportunity to help them dial their inline cleaning process, looking to solve a series of problematics that we're facing in the recent years. The three main reported issues were they were having a higher than usual chemical consumption in the process compared to other similar cleaning process this corporate has as reference in other sites of the world. They were looking for a consumption reduction that would help them bring their process ownership costs down. Secondly, they were having foaming issues in the rinsing section with which end up causing all kinds of problems like stains on the boards, leaks, and spills on the production floor. Lastly, the most important problem was in several models after the cleaning process, flux residues were still on the boards. Boards were being rejected by the quality department and their end customer. This was not acceptable due to reliability concerns besides the obvious neglected cosmetic appearance. After listening to the CM requirements and main concerns, it was clear for us at KYZEN that we needed to guarantee the complete removal of flux residues from all the PCB models they were running through this process. It was going to be required for us to map down the entire current process in order to identify potential root causes and the main influencing factors to be able to optimize and address each pain point reported. The first step for us was to recommend an adequate cleaning agent that would guarantee the solubility of all flux residues this CM facility was running through this inline process. The DCM had different models that passed through this inline and all use different solder paste and fluxes. CM shared with us the brand and model of all fluxes being used on their models. Once all residues were identified and the fact that they were using a spray in air inline, we recommended an AQUANOX cleaning product, a water-based cleaning agent capable of removing all identified residues, providing a safe and reliable cleaning solution. KYZEN has a massive database of flux residues with which we have previously run cleaning trials. With this historical information, we were able to provide a baseline of parameters to start testing when working with a new customer and application like this one. We share available cleaning trials reports previously done for each type of residue so the CM could analyze the data and confirm our initial recommendation. A series of sample boards were sent to our lab to test. The results on the cleanliness of the boards with our AQUANOX product were staggering and evident. Just by switching to the correct cleaning agent, the white flux stains that they have been experiencing for the past years using the pH-neutral competitor cleaner disappear completely from their board surface. This was very surprising to the CM, who had already identified this as a usual defect on the board and thought it to be impossible to fix. Needless to say, the CM was very happy with these promising cleaning results. Fluxes on the market keep evolving, introducing new formulations that are more challenging to dissolve, hence to clean. You could have used a chemical for the past decade and suddenly start noticing residues being left with new flux formulations. This could mean that your cleaner is not capable of dissolving all the components on the new flux formulation. We suggested to the CM to run a DOE with different parameters combination, conveyor speed, temperature, concentrations, looking to identify the combination that would offer the best cleanliness result at the minor cost of ownership of their process. The lowest chemical concentration that was able to clean the residues completely from the parts was 10% concentration of our AQUANOX. The CM requested us to perform a control run at the facility to gather real production floor data and validate the results. But before running the DOE, we recommended to the CM to perform a complete audit to their current process, so we could ensure their equipment was in optimal conditions, ensuring the success of the trials at their facility. As a starting point, it was important to review the state of their inline cleaner. In this case, they have a conveyor spraying air inline washer with pre-wash, wash, rinse, and final rinse sections, followed by hot air recirculated air drying stage. KYZEN is familiar and work together with all the main inline equipment brands out there in the market. So we were able to review their process together with the CM in detail. For this type of task, KYZEN has developed what we call a KYZEN inline equipment audit, in which we basically perform a full review and checkup of the state of your inline section by section. We performed this checkup together with the maintenance and engineering teams of the CM, so they could get a full picture of all the process and identify the pain points that require attention. Some of the factors we review are the configuration and alignment of the spray bar nozzles and air knives on each one of the sections, the exhaust system, maximum pressures and temperatures that your equipment is being able to achieve, quality of DI water being used in the process. This includes their water treatment plant in case they have one. We also review the best practices they should follow to take good care of each part of the process. Basically, we looked meticulously for potential issues that could be limiting the full capabilities of your cleaning equipment. At the end, we provided a full report with the findings on the audit performed and suggested corrective and preventive actions that needed to be addressed in order to get the best results with their available tools and resources. The following are some examples of the findings and recommendations we did to the CM after the audit was performed. While checking the spray bars and nozzles, we noticed many of them were clogged with different soils and residues, from mud-type residues to Teflon tape remains, or even small electronic components that made their way up to the spray bars through the pump. This was an important problem for their cleaning process because they rely on the washing equipment being able to deliver the cleaning solution into the board surface with the appropriate flow and pressure in order to achieve the cleanliness levels they were looking for. When we have most of our nozzles blocked, then we can have sections of the conveyor belt that are not being covered or reached by the streams. We are limiting the capacity of the washer to perform its job of removing the desired residues. As you can see on the picture on the bottom right, some spray streams were deviating due to this obstruction and not hitting the boards as required. We noticed there was a scale buildup on the tanks, the heaters, and even in the pump inlet filters. This scale buildup accumulates usually due to a poor quality DI water quality used, or it could also come from the cleaning agent you are using in your process. Some chemicals tend to generate scale on your equipment. This is not something desired and should be avoided if possible. We also found a thick layer of mud on the bottom of the tanks, consistent with the same mud type residue found in the spray bars on the nozzles. Many electronic components were found in the bottom of the wash tank and rinse tanks that have fallen from boards that were being washed through the process. Due to the state of the washer, we recommended to perform a complete cleanup of the system to remove all contamination accumulated in the system, which were causing all kinds of issues like the previously described. We provided to the CM with a specialized cleaning chemical named KYZEN Rin 600. This is used to recirculate through the entire equipment for 3 to 4 hours. This helps to dissolve all these scale buildup in the walls of your tanks and also inside the tubings and spray bars and pumps. We recommend a full maintenance cleanup of your equipment like this one at least once per year to ensure your cleaning equipment stays in shape and is optimal. As you can see in the pictures, the equipment was left completely clean with no scale buildup and ready for it to be filled with a new AQUANOX solution for the trials to be run. We were running the trials at the CM site. We noticed that there was a layer of solvent floating in the surface of the wash tank. This is common and is expected in the type of in this type of water-based products due to its composition and physical properties. But it called our attention that the concentration measurement was struggling to reach the expected value, which was 10%, after adding the exact amount of chemical to the wash tank. We noticed the layer of the solvent was thicker than usual, and we decided to take a sample in a beaker, which is the picture in the right. As you can see, there was a thick layer of solvent, which is not normal. While analyzing the process, we noticed that the wash tank of this particular equipment is elongated and big volume, which makes it difficult for the wash solution to mix homogeneously in all the areas of the wash tank. The lack of turbulence was causing solvent to accumulate on the top corners of the tank. This was making an effect in the concentration percentage readings, which caused them to be lower than expected. This was being experienced by the customer also with the competitor cleaning agent, and they were constantly adding extra chemical looking to maintain the desired concentration. All this behavior was provoking a higher consumption than usual in the process. After determining the root cause of the concentration percentage issue, we recommended the use of KYZEN adductors. These are essentially flow blowers that are recirculating the liquid inside the wash tank, creating extra turbulence in the desired areas to ensure an appropriate homogeneous mixing of the solution. After adding the adductors to the system, the concentration readings stabilized and the extra addition of chemical to the system were not required anymore. After running for some days in the process, the CM reported to be having foaming issues in the rinsing tanks. This was causing overflow into the wash section and diluting the wash tank. Usually when a foam issue in the rinse tank appears, there are a few things that could be going on. Excessive drag out from the wash section into the rinse, or a DA water quality issue. Initially, the drag out of the chemical from the wash into the rinse was addressed by controlling the excessive add-ups of chemical into the process. But also, due to the long design of this equipment, we were able to turn off the last section of the wash to simulate a chemical isolation section, which this old model did not have included. The boards could drip down the excess of liquid back to the wash tank before reaching the rinsing stage with this change. Nevertheless, the foaming continued to appear in excess. Therefore, we focus on the second most usual cause for this, which is the DI water quality. Usually, DI water is defined as an ultra-pure water which contains very little amounts of ionic and organic residues. The quality of the DI water is measured by the conductivity or resistivity of the water. Water with resistivity values above 1 megaohm will be considered DI water. Or, seen from the conductivity perspective, water with conductivity values below 1 microsiemens is considered DI water. As you may already know, DI water is usually obtained by filtering it through a combination of carbon and resin mixed beds. Carbon removes the organics, and resin mixed beds remove the ionic residues. Foaming in the water is related to organics being present in the water. So the foaming issue was probably related to the carbon beds in the water treatment system. We ended up having to map the entire water treatment system in the CM facility. We had to understand how water was being treated and recirculated along the entire system. In effect, the CM had a combination of RO system with a carbon and mixed bed filters and big containers where the DI water was being stored to have a buffer to feed the machine. When we inspected the containers in which the DI water was being stored before reaching out the washing equipment, we found that these containers were contaminated with a lot of algae residues, and other organic residues. The entire DI water system was compromised, and also smell of chemical was present in all the containers and filters. We ended up recommending a complete purge of the DI water system and the replacement of the carbon and mixed bed resin filters to ensure we were getting high purity DI water into the system. Also, we offer some alternative configurations of the DI water treatment recirculation from the washer to the filtration system, because chemical was being sent back to the DI filters, and this was causing the filters to deplete very quickly. The higher chemical concentration streams should not be recirculated into the water treatment system. That one needs to be isolated and safely disposed separately. After all these changes, the foaming issues was eliminated and controlled, allowing the CM to run continuously their PCB cleaning process, improving its efficiency. Once the flux residues were eliminated, we came across another finding. Some of the labels used on the CM were vanishing or being completely erased after passing through the PCB cleaning process. This type of effect on the labels might be expected when you do a change of chemical in your process. Each chemical product has different properties and characteristics which need to be taken in consideration for the materials you will be using in the process. One label that is compatible with certain cleaning agent might not be compatible with a different type of chemical. KYZEN works closely with all the main label brand manufacturers, performing compatibility studies to generate a database of labels and ribbons that can be recommended with our products for any type of cleaning application. We requested the brand of labels used by the CM and offered them the recommendation of certain label models and ribbons. They were previously tested by KYZEN on the laboratory, and that we knew they have shown good resistance to our AQUANOX products. KYZEN team put in contact the CM with the label manufacturer so we could run a trial at their facility with the recommended labels. The label manufacturers sent free samples of the labels and ribbons to the CM so they could run the corresponding tests. With the sample labels provided by the label manufacturer, a DOE was run at the production floor. Two different labels and ribbons were used during the trial. After the cleaning test with our AQUANOX directly in the CM inline PCB cleaning process with a concentration of 10% and a speed of 0.7 feet per minute, the ink on sample 1 and 2 show complete resistance to the process. At the end, the label manufacturer recommended a specific combination of ribbon and label. After implementing these changes, the issue was completely resolved, ensuring the identification and traceability of the PCBs along the process. Even when we fixed all the issues previously described, the CM decided to run again with their previously pH-neutral cleaning agent to compare the results after all improvements we did on their process. The results are shown in the screen. Our AQUANOX show better performance and even under the equally improved circumstances. An ionic contamination test was run after the washing cycle of the boards for both cleaning products, and the results with our AQUANOX product show 50% less of contamination detected in a ROSE test. As you have seen along, the optimization of the process was possible and achieved due to the cooperation and openness of the EAC manufacturer. This did not happen overnight. It required the involvement of multiple departments on the CM side, and of course, the support and advisory of KYZEN cleaning expert team. The team provided all the required additional theoretical and practical training to the key users involved on the cleaning process, from technicians to engineers and managers. It is important that everybody understands the key and vital factors of the cleaning process in order to maintain stable its functionality and reliability along the time. This is the excellence in support offered by KYZEN to all customers in any type of cleaning application. With this, we have come to the end of this case study. But before we leave, we will be reviewing 3 frequently asked questions about this topic from our subscribed viewers. The first one reads, does this optimization and improvement apply to any type or brand of inline washing equipment? Yes, this optimization and improvements apply for any type of PCB cleaning application, whether it is a batch cleaning system or other brands of inline cleaning systems. Each equipment design is different and has unique features that could help address these type of challenges differently. Bottom line, as you all know, any system is susceptible of improvement, and having the best technical support and advisory to determine what would work best in your tailored process is key for your success. The second question reads, are the adductors that were installed in this case as an aid for the mixing in the wash tank always recommended for this type of process? It depends on two things, the design of the equipment and the chemical you are using. Some equipment brands have a better mixing capability on the wash tank than others. The bigger volume capacity of the wash tank, the more difficult to maintain the right amount of turbulence that will ensure an adequate mixing. On the other hand, the type of chemical you are using is an important factor. Some products tend to separate faster due to their chemical and physical properties. If you know you have a product that requires a fair amount of turbulence to properly mix, then the use of adductors would also be suggested. The third one and last one reads, I have a similar issue with label compatibility, but the problem is not ink removal. Labels are being detached during the process. What do you recommend in such case? Well, the chemical you are using should be compatible with the ribbon or ink used in the markings of the labels, as well as with the adhesive used to adhere the labels to the surface. In your particular case, we would have to address the adhesive that your labels is using. I recommend you reach out to your label supplier and request from them a label with an adhesive that can resist washing process and is compatible with the chemical product you are using. Thanks to all for tuning and listening to this episode. As always, it has been a pleasure to share these technical insights with you all, and I send it back to you, William.
Thanks, Luis. And thank you guys for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.